Hey, what's up? Yes, we here for programming solutions, very new exciting lesson. And in this tutorial, you will learn types of instructions in C language. Friends, people say that you can't live without love. But I say, oxygen is more important. So let's leave the love topic and let's start lesson. Friends, you have written few programs in C language now, but it was just an introduction. Your actual learning starts now. When you wrote that program, each line which ended with a semicolon was an instruction. Now let's look at the instructions that we used in this program. There are basically three types of instructions in C language. First, type declaration instruction. Second, arithmetic instruction. Third is control instruction. Type declaration instructions are used to declare the type of variable used in a C program. Arithmetic instructions are used to perform arithmetic operations between constants and variables. And control instructions are used to control the sequence of execution of various statements in a C program. Now we will look at the first type, type declaration instruction. This instruction is used to declare the type of variables being used in a program. Any variable used in a program must be declared before using it in any statement. The type declaration statement is written at the beginning of main function. Example is like this. Here I have declared variables: integer bas, float rs and gross l, character, name and code. Now there are several subtle variations of the type declaration instruction, and these are discussed below. While declaring the type of variable, we can also initialize it as shown. Integer I is equal to 10 and j is equal to 25. Float a is equal to 1.5, b is equal to 1.99 plus 2.4 into 1.44. Now the second variation is, the order in which we define the variables is sometimes important and sometimes not. For example, integer I is equal to 10 and j is equal to 25. It's same as integer I is equal to 25 and j is equal to 10. However, float a is equal to 1.5, comma b is equal to a plus 3.1 is alright, but the second variation, float b is equal to a plus 3.1, comma a is equal to 1.5 is not, because this reason is very important, because here we are trying to use a even before defining it. Now the third is, the following statement would work: integer a comma b comma c comma d, and a is equal to b is equal to c is equal to 10. However, the following statement would not work: integer a is equal to b is equal to c is equal to d is equal to 10. Once again we are trying to use b to assign to a before defining it. So these points are very important, and in many MCQs you will find this logic. Now the second type is arithmetic instruction. A C arithmetic instruction consists of a variable name on the left hand side of is equal to and variable names and constant on the right hand side of is equal to. The variables and the constants appearing on the right hand side of is equal to are connected by arithmetic operators like plus, minus, multiplication and division. Example is like this: int ad, float chord data alpha beta gamma, ad is equal to 3200, chord is equal to 0.0056, data is equal to alpha into beta divided by gamma plus 3.2 into 2 divided by 5. Here in the above example, multiplication, division, minus, plus are the arithmetic operators. Is equal to is the assignment operator. 2, 5 and 3200 are integer constants. 3.2 and 0.0056 are real constants. AD is an integer variable. Chord, data, alpha, beta, gamma are real variables. The variables and constants together are called operands. that are operated upon by the arithmetic operators, and the result is assigned using the assignment operator to the variable on the left hand side. Now, there are some types of arithmetic statements. A C arithmetic statement could be of three types. These are as follows. Integer mode arithmetic statement. This is arithmetic statement in which all operands are either integer variables or integer constant. Example is like this. Integer I, king, Isaac, note it. I is equal to I plus 1 and king is equal to Isaac into 234 into note it minus 7689. So here in this example, all operands are integers. So that's why it is called integer mode arithmetic statement. Now the second one is real mode arithmetic statement. This is an arithmetic statement in which all operands are either real constants or real variables. The example is like this. Here in this example, all operands are real. That's why it is called real mode arithmetic statement. Now the third one is mixed mode arithmetic statement. And obviously this is an arithmetic statement in which some of the operands are integer and some of the operands are real. The example is given like this. Now it is very important to understand how the execution of an arithmetic statement takes place. Firstly, the right hand side is evaluated using constants and the numerical values stored in the variable names. This value is then assigned to the variable on the left hand side. Though arithmetic instruction looks simple to use, one often commits mistakes in writing them. Let's take a closer look at these statements. Note the following points carefully. C allows only one variable on the left hand side of is equal to, that is Z is equal to K into I is legal, whereas K into I is equal to Z is illegal. The second is, in addition to the division operator, C also provides a modular division operator. This operator returns the remainder on dividing one integer with another. Thus, the expression 10 divided by 2 yields 5, whereas 10 modulus 2 yields 0. Note that the modulus operator cannot be applied on float. Also note that on using modulus, the sign of remainder is always same as the sign of numerator. Thus, minus 5 modulus 2 yields minus 1, whereas 5 modulus 2 yields 1. The third is, an arithmetic instruction is often used for storing character constants in character variables. Char A, B, C. A is equal to F, B is equal to G, C is equal to plus. When we do this, the ASCII value of the characters are stored in the variables. ASCII values are used to represent any character in memory. The ASCII values of F and G are 70 and 71. Now you have to search the ASCII table on Google and check all the values. Arithmetic operations can be performed on integers, floats and chars. Thus the statement char xy integer z, x is equal to a, y is equal to character b and z is equal to x plus y are perfectly valid because the addition is performed on the ASCII values of the characters and not on the characters themselves. The ASCII values of a and b are 97 and 98 and hence can definitely be added. Now the question based on these tricks can be asked in many interviews of many companies. No operator is assumed to be present. It must be written explicitly. In the following example, the multiplication operator after b must be explicitly written. A is equal to CDB in bracket xy is the usual arithmetic statement, but in C language you have to write like this: b is equal to c into d into b into in bracket x into y bracket close. Unlike other high level languages, there is no operator for performing exponential operation. These following statements are invalid. A is equal to 3 star star 2 or b is equal to 3 raised to 2. These statements are not valid. If we want to do the exponentiation, we can get it done this way. Hash include mat.h main function, and then a is equal to power of 3, 2 and printf a. Here power function is a standard library function. It is being used to raise 3 to the power of 2. Hash include mat.h is a preprocessor directive. It is being used here to ensure that the power function works correctly. We will learn more about standard library function in coming lessons. Control instructions in C. This is the third type. As the name suggests, the control instructions enable us to specify the order in which the various instructions in a program are to be executed by the computer. In other words, the control instruction determine the flow of control in a program. There are 4 types of control instruction in C, and they are: first is sequence control instruction, second selection or decision control instruction, third repetition or loop control instruction, and fourth case control instruction. The sequence control instruction ensures that the instructions are executed in the same order in which they appear in the program. Decision or case control instruction allow the computer to take a decision as to which instruction to be executed next. The loop control instruction helps computer to execute a group of statements repeatedly. In the following chapters, we are going to learn these instructions in details. Now, before proceeding to the next lesson, you have to code something, and I will give you one exercise. Look at the information given with this video for the exercise. In the next lesson, you will learn the decision control instructions in details. So guys, next lesson is very important. Must watch.